Hi everyone. Good afternoon. Okay, first of all, let me introduce myself. My name is Krishna. I'll be your tutor for this 1 hour webinar session and have close to 15 years of IT experience, and I work as a senior system development engineer, which is more of a principal engineer in other companies. So that's more about it. Let's open our session today, which is on machine learning with Scikit-learn Decoded. So here is our objectives today or agenda, which we are going to discuss. What is machine learning? What is scikit-learn? How do you install it? And what is regression and classification? And what is SVM and KNN, which are one of the supervised learning algorithms? And we will do a hands-on if we have enough time to do that. Now, starting with introduction to machine learning. What do you mean by machine learning? Let me tell you. So machine learning is one, if you look at the entire actual curve of the entire artificial intelligence stuff, your artificial intelligence, if you take this as a big circle, in that one part of it is your ML, and inside that you have something called DL. I'm giving you an overall view of machine learning and all that stuff, including the superset, which is AI. AI is artificial intelligence. It is to make devices or computers think and interpret things like humans. How do the AI question is the AI objective, if you want to put it that way, is to make computers think like humans. That's what the main goal of AI is. In that, you have from there the machine learning has come. Machine learning is all about multiple algorithms, or a set of algorithms that would help to understand, that actually helps to understand the pattern in data. Like it will help you to generalize the based on the data set, it will help you to understand the data, and it will generalize, not only understanding the patterns, but also it should be able to predict also. So all your algorithms, if you look at any algorithm, right from SVM to logistic regression or linear regression, any algorithm, their ultimate goal is generalizing the data by understanding patterns from it, and finally do some kind of forecasting or prediction. That's what ML will do. Now deep learning, what it will do is, it is also one of the machine learning. That's nothing different. Why deep learning is, in deep learning, the way you learn about data will be in the form of different structured layers. Because of multiple layers it has to go through to do that learning process. That's why the name deep learning. And one more thing is, in machine learning, one of the biggest challenge is to understand more about the feature extraction or feature identification. Machine learning algorithms lack certain skills which deep learning algorithms excels at. Like if you take your CNN algorithm, it very much excels in identifying the feature information properly. So that's why it is used mostly on face recognition and all that when it comes to deep learning. So this is like an overall high level picture of what is your AI, what is ML, what is real kind of thing. Okay, I hope it is clear now. Now, if you look at what is that it is showing here, it is showing like, okay, you have a data, you have a machine which gets trained, then it builds a model, then it outcome. So what is a model here? We are saying model, but what exactly is a model? This one. What does it mean by a model? Not the fashion models like the, generally we talk, right? Fashion models. It's not about that. Then what is that model here? I mean, here model simply means a representation of the data in the form of a program. That's what model means here. Whenever somebody says I build a model, what they are saying is they have come up with a program where it is more generalized to understand patterns from the data and is able to predict something out of it. That's what it means by model. Generally, what used to happen before even machine learning has come, if you ever see, our programs are like that. You give input, there is your program which processes it and gives you the output. This is what happens. Okay. Whereas in the machine learning case, what happens is you give input, you give your program, you give your input, as well as you give the output also, like how the output would be. And machine learning, when you pass this to a machine learning thing, it will come up with a program to you, and it will have something called a feedback channel as well. Okay, I'm just putting a high level. So it does not mean it will generate a program. It will give you, there might be a program here. So here also you will have a program. That program objective is not to process the input, take the out and give the output. That's not the objective of it. That program objective is to understand the pattern from the data you're given. That is what that program will do. So here when I say ML, that is nothing but your program. There is a program where you pass the input as well as the output that is expected for those input, and it automatically figure out the generalized program which can count out of it, which is nothing but a pattern. And sometimes there will be a feedback mechanism also to improve it over a period of time. And sometimes this output will not be there. When the output will not be there, you will call it as a model, whatever. Okay, like that. Now here, the same analogy if you apply, this data, like I said, right, here we are giving data and we are giving to machine. That means here there is some program which from your data it is understanding. Like for example, a simple example if you want to put, if I give it data like this, like let's say email spam, like let's say you have something like this, whenever email and spam or not, if I put it like this, now the purpose of this particular machine learning algorithm is to identify whether it's spam or not. If I put some content in this particular line saying this kind of content it comes, it means yes, it is a spam email. If the content is proper, I mean, I'm just don't look at the format, but just say there is some content where there are certain keywords, something like a keyword of, let's say something like a movie, entertainment and all. If I say those are all should be considered as spam emails, and sometimes like if it is not having movie or entertainment and all, consider it as a no spam. So this is the output here for the input, which is nothing but email. So if you train it, what your machine learning algorithm will try to understand is, okay, when the user contains the email, from the email if the keywords are like movie, entertainment, I have to consider it as a spam email. That's what this output signal is telling me. If the content does not contain, it is telling me it has to consider it as a not spam email. So it generalizes based on the data you have given. So data plays a very crucial role in machine learning. If you are properly given data, the answer also will be proper. If you didn't train it properly, that means if your data itself is wrong, which you are using for training, the output itself will be wrong. So this output is what people call in machine learning as labeled, unlabeled data. So here labeled responses or labeled means nothing but the output you pass. Unlabeled means there is no output signal. You will be just passing input to your machine learning programs. And here with the same analogy, if you take a look at it, your data is there that is passed to machine, and machine will come with a generalized program which will able to not only understand the pattern because it generalized all the things from the data, and it is also able to predict both. There are two jobs of your machine learning program: understanding the pattern so that it can generalize on unseen data. That unseen data, when it comes, it will start predicting. That's the whole job of this machine learning algorithms are. And data plays a very good role. If you are given wrong data where it gives wrong predictions, it is just like kid. If you train bad habits, what will happen? That guy will become a bad guy. The same thing here. So data is very, very important. So same thing what we discussed. Now in machine learning, again, there are three kind of section at a high level. In some books, you might see there is one more division will come, which is called semi-supervised learning. So machine learning, you have supervised learning, reinforcement learning, unsupervised learning. At a high level, when you say supervised learning is where you're being told what to expect from an input. Like for example, a very classic example which everybody tells also, you know, while you are working by yourself, while you are going to school, if there is a teacher who teaches you how to do a math problem correctly, that's called supervised learning, because you are being guided by a person to tell your mistakes and correct yourself and do it properly. That is supervised learning. Unsupervised learning means there's no teacher, nothing. It's like self-learning. Nobody is teaching you. You're just watching YouTubes, you're just watching tutorials and learning by yourself. It's like self-learning. Unsupervised learning, there will not be any guidance. You have to figure out things by yourself. Reinforcement learning, here reinforcement learning, what will happen is there will be an ML agent, which is nothing but a program inside, where that guy will be just thrown on the field. It is as simple as, okay, if I am leaving a person who lived in the jungle for all the years and I left him on the road, obviously he will go and hit some car or whatever, because he never have seen that kind of environment. So what he will do, first time he will be hit, first time he will be not able to do it, but over a period of time when he crossed the same road for a month every day, he automatically learns, right? So that's what reinforcement learning, where you directly pump into a particular algorithm into field and you will give something like a reward whenever he do the things properly, and you will give a penalty whenever you do some mistake. It is similar to at our home, whenever we do things properly, our father will give you a gift or present, and whenever we do mistake, we will get beatings. That beatings are your penalty and the gift is your rewards. That is reinforcement learning. Apart from that, there is one more thing called semi-supervised learning. Semi-supervised is you have partial data that tells your input, that tells your machine learning algorithm what is the expected outcome for this input, and the other part of it where you do not have any guidance as such. So it is a mix of both. So supervised learning, we already talked about it. The same thing here, whenever people say labeled responses, it is nothing but like I showed you that spam email, right? Whether it's a spam or not, that output value, that is your labeled responses. In the case of supervised learning, it will be available. In the case of unsupervised learning, that labeled means that output will not be available. You just have an input. And here the clustering and association rules are used to figure out things. And what is Scikit-learn? Scikit-learn is one of the popular machine learning algorithm is used. It's built on top of NumPy, SciPy, and Matplotlib. And you have got a lot of tuning parameters, and it's an open source library. That means if there is any problem, you can always recommend something and they can fix it if it is relevant enough. How to install? You just need to run this pip install. All you need to do is, I am using Colab, which is a Google given one. But in case if you are interested, all you need to do here is, in case if you are doing an Colab, just say pip install scikit pip install 𝐶learn. That's it. So it will automatically install. Okay. So you can either do that or scikit-learn. You can just say that and it automatically installs for you. Okay, that's how you should be installing. So it's already installed. One good thing about Google Colab is this Colab will be free, whoever has Gmail, and that have a lot of machine learning libraries already installed. That is one good thing about Colab. Okay, so once you install it, it is ready, and as part of it, you will get NumPy and SciPy also. And if you want to import a model, this is a very big module, guys, Scikit-learn. In that family of it, you have several submodules called model, and you have modules called linear regression, and you also have modules for many machine learning algorithms, right from SVM to KNN and all that. Now, what is regression and classification? If you remember, in the machine learning classification, I showed you two things. Well, I showed you three things: supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, again, there are two types of learning. One is called regression, another is called classification. Classification is, given an algorithm, if it is able to classify things into if it is able to classify things into categories, like for example, if you say, is this email spam or not, that's a classification. It's called binary classification. Similarly, if it is able to identify, let's say, whether a particular person is employee, is student, is senior citizen, like that, if you have multiple categories, it can even do that. The classification algorithms even can do that. That's called multi-classification algorithms. Regression means if it is able to identify data and get you the output in the form of a real value. That means it could be 1, 2, 3, 4, any real number value. If it is can get you, that's called regression. Okay, so I just spoke about it now, right? Now we discussed classification, whether it's cold or hot. This is only two possible values, hot or cold. You can say rainy, you can say chill, I mean whatever. But again, there are set of categories comes in. Whereas here, when you say regression, it's more about the temperature values, which will keep changing. They will not be fixed. Sometimes it would be 84.5, sometimes it would be 60.5. It could keep changing, right? That comes under regression. Again, in classification algorithms, if you look at what are the algorithms that can come under classification is, these are the ones, which is logistic regression, decision tree, random forest, KNN, naive Bayes, SVM. So all of their job is identify a particular given data to see in which particular category they go into, and each have a different way of doing things. Like for example, logistic regression, it actually tries to predict the outcome of a dependent variable, which which bucket it should go. So here dependent variable means, so there are two things. I mean, you need to have the basic static knowledge. So there are two terms now and then you will hear in machine learning. There are a lot of terms used, and these are the another two terms used. One is called dependent and independent variable. So just to give you an idea, this is for beginners. Most of you might be knowing. Like if I say x equal to 1 plus z plus y. So here this x is called as a dependent variable and z and y are independent variables. The reason being, your x value is completely dependent on the values which y and z gives, right? If your y and z is 2, then it will be, the answer will be 5. If your y and z is 3, the answer will be 7. If your y and z are 7, the answer will be 15. So your x value is completely dependent on that. So this x is called dependent variable. This z and y are not dependent on x. They are independent. These two are called independent variables. So what he is trying to say is the logistic regression is used to predict the outcome of a dependent variable like this, which is categorical. That means in the set of possible values, whether email, spam or not, that is categorical. So those kind of thing it will try to predict based on the dependent variable is what he is trying to say. Okay, these are very important. It looks like very basic, but these terms a lot of times confuse you. Like I said, categorical means this 0 or 1, yes or no, true or false, high and low. These are all categorical. Categorical simply means if you are able to fit a set of values into limited set of buckets. When I say limited set of buckets, very simple example, if you are ever traveling to a flight, what are the different passenger status? He can be in economy class, he can be in luxury class, he can be in business class. That means 3 categories. That is a categorical variable. Your passenger status is categorical variable because it can hold any of the 3 possible values. Similarly, if you say whether you are educated or not, again there are 2 possible values, educated, uneducated. That is categorical value, your educational status. Similarly, if you say are you a postgraduate or not, again 2 possible values, postgraduate or undergraduate. Or if you say what is your qualification, qualification is a categorical value because your qualification could be MS, BTech, MSc, MTech, anything. These are all qualification, but they all fit into one bucket, one of your degree, right? Any the main max degree, the last degree you have done. So those are categorical values. Like here also you see those are the ones. Decision tree, like the name says, it actually hops to multiple decisions. It's actually graphical representation of saying based on all the possible values, I'm coming to this decision kind of. Random forest is one of the most popular supervised learning, and most of them, even though we say classification here, don't assume that they only can be used for classification. Some of these algorithms like SVM, KN, and random forest can be used both for classification as well as regression algorithms also. This is also made out of decision tree. KNN, this uses the technique of identifying the nearest neighbors based on the distance measures, or you can say similarity measures. Like for example, if you say here KNN means K nearest neighbor, here K is the value which you give, which most of the time when the data set is an even number, you choose the K as odd. And here in this case, the idea is you should be able to draw a line which can easily separate your data, and you can easily classify the data saying whether this will go under class A or class B. If I properly able to do that, that means my machine learning algorithm is properly able to do it, something like this. It should be able to get to your linear equation that best fits so that it properly categorizes the data, at the same time minimizes the error also. That's what this KNN try to do. And most of the machine learning algorithms, some way or other, tries to attain this objective. And if you look at overall machine learning algorithms, mostly at the bottom level, it's all your mathematics comes in. It could be in the form of statistics, it could be in the form of linear algebra, it could be in the form of probability. All this will come. Like Naive theorem, Bayes theorem is actually from statistics. From there they pulled out and they are using this in order to do the classification measure. Similarly, SVM, which stands for support vector machines, or sometimes people call it as support vector measures also. This also helps you to classify. It actually draws a hyperplane. So hyperplane is nothing but a simple line. So if you say I have some data points like that on my 2-dimensional data, like you have some data like this, you have other type of data here, and if you are able to come up with a line, a popular linear equation that actually helps you to distinguish between these 2 data, which is like it could be male and it could be female based on the gender. If you are able to properly distinguish from your data, this line is called as hyperplane, the line which draws that point of separation between these 2. How it does and all is different story, but understand the high level. Like I already talked about, it tries to identify by using a hyperplane, which is nothing but a line. And you see that's what the same thing has been put. And it uses something called margin, maximum margin and all that to do it. And these are, so this is the hyperplane I was talking about. So you see here 2 support vectors. Vectors is nothing but your data set points. And it tries to put a proper line that actually able to distinguish. How it does, again, it just depends on what kind of distance measure it uses. And the objective of it is to maximize this margin. This is called as margin. Maximize this margin by minimizing the error. That's what the main objective of SVM will do. And again, at the bottom level, if you do, and again, SVM uses different kernels and all. So these are the kernels. So it can use linear kernel, polynomial kernel, radial basis function kernel and all. Like if you see linear kernel at the bottom level is kind of a mathematical equation, which is something like this: sigma I to from 1 to n. It is like xi minus yi. It is sum of squares, basically square of it. This is how it will be. This is for linear kernel. Similarly, polynomial kernel, you will see some other mathematical equation, radial basis kernel, some other, and it uses something called kernel tricks also. So these are applications we should have put as applications, but here it's okay. So this SVM you can use to do a lot, like right from classifying images to face detection, homology detection, bioinformatics, handwriting, generalized, even for news, when you use a news to identify whether a news is related to entertainment or it is neutral related to politics, news related to sports, it can even do that if you properly train it. And what actually you do in SVM? Obviously, any machine algorithm goes for this first phase where you load the data, then you do some kind of explorating data analysis and splitting the data. This will be common for most of the machine learning analysis, where why we need to split the data is, let's say you have been given 100 records in a table. That 100 records, when you do it, you will be training machine, that program. So training means what? It will be trying to understand the pattern from it. It will try to generalize as much as possible. Now, when it is training, how do you validate whether it is really ready to used? Now, what you will do actually is, when you're given this 1000 records table, you do this 80-20% rule, where what you do is you will train your machine with this 80% of the data. Okay, and that's why the split will happen. Split is necessary to actually break your 1000 records by this rule of 80-20, where you break your 80% of the data as training data, which is used to train it, and after that, to validate whether your algorithm is working or not, you will use this 20. The idea here is, it has already seen this data and it has understood. Now you are throwing it a new data which it has not seen, so that it should be able to understand. And believe me, a lot of algorithms sometimes not able to do it, because sometimes what would happen is they are so tied up or so attached to this training data, they will be too much biased to it, and sometimes there could be a problem. That problem is what people call it as overfitting. Overfitting means you understood too much about your training data in such a way that you're not able to generalize to an unseen data, this 20%. It will not able to do properly. That is called overfitting. And there are cases which is called underfitting, which means you aren't able to generalize the data itself. That means you're not useful. That could also happen. So these are the two things which you have to balance. Don't assume every machine algorithm is be good enough to train. Sometimes machine algorithms understand too much about the data that they will never able to predict properly, which is the overall purpose not met. And sometimes they will not able to understand anything out of it. So it's our responsibility to tune it, to understand what is missing and to do all that. And it all comes with experience. It's not that easy that you just put some algorithm and it automatically comes. No, you need to understand what algorithm it uses. You need to be able to tweak and write every single step of how it achieves by hand. If you have that kind of good knowledge, you can easily do. But if you are just relying on Python and executing it, this kind of debugging will be difficult for you. Let's say you have trained this particular some algorithm, some machine algorithm you have trained on this data. And let's say they understood so much about these cats and dogs from this data. Now they are able to understand. But let's say I gave it a different cat picture overall, which does not have something like, I'm just putting some cat picture. Assume it is a cat picture. It has small ears, but not exactly like this. That time it will not able to generalize it because it is attached too much to your data. Overfitting simply means on the training data you have attached too much that you are able to do very good observations or very good inferences on the training data. But when you give a new data altogether, it is not able to figure out it at all. That is called overfitting. When you say underfitting, it means you are not able to understand the training data. So what does mean by understanding is it is not able to predict properly even on the training data itself. That's called underfitting. So KNN, it uses, this is also a supervised learning algorithm. All we are talking about is a supervised learning algorithms only. And in fact, KNN and SVM both can be used to, classification as well as regression. And here, if you see what is non-parametric and what is supervised learning, we already spoke about it. Parametric, non-parametric. So parametric, there are two types of algorithms again in machine learning. One is called parametric, another is called non-parametric. Parametric means your machine learning algorithm assumes the structure of your data by itself. That algorithm by default assumes the structure of the data, because of which on smaller data it can able to give proper results and all. But when it comes to unseen data, you might not able to do well because they come up with some assumptions. Parametric means they come up with some assumptions about the data, saying that the data structure will look like this, the shape will be like that and all. There are some set of machine algorithms that fall into that category. And there are other set of algorithms like KNN, which is non-parametric. They do not assume any structure of the data. Because of that, the advantage is you will be able to generalize. When I say generalize means even if you pass a new data, it should be able to do things properly. That's called non-parametric. And here there are two terms. One is lazy algorithm and another thing was called eager algorithm. So this is another terms people use. So eager algorithms means you have to train the algorithm before even you start prediction for it. Otherwise they will not be ready to give some predictions for you. That means you have to give some data to it way before, let the machine train, and after that you can give some new data and it will start the prediction. That is how the eager algorithms work. There is other set of algorithms like KNN which do not need training at all. They directly can work on the test data or the training data. The reason here is on the lazy algorithm here means what will happen for KNN when you give your data and ask it to say how the KNN represents. KNN representation is the entire data set itself. So whenever you ask it to somebody predict it, it goes and checks in your entire training data at the runtime on the spot. It doesn't need any training. Because of that, it is fast, but at the same time, it has its own cons also. Because like I said, when you say KNN, it is the representation of the entire data. That means entire data. Whereas in the case of eager algorithms, you will not be using entire data to analyze your stuff. You will be doing lot of feature removal. You will do that. You will remove a lot of features which is unnecessary. You do a lot of things and all, but in KNN you directly pass the data and it will do then and there. This is called lazy algorithm. It might be fast, but when the data grows, this also will become slower. And there is one more thing you have seen, which is called feature similarity. One thing always remember in machine learning, I don't know why people don't refer it here. Feature means your variables or columns or attributes. In fact, the column attributes, I would say. So when you say feature similarity, it is nothing but when you have a table and table have got multiple columns, people when they refer feature similarity in machine learning, feature they mean the columns or the variables or the input variables. Those are the columns they are referring to. So here when they say based on feature similarity, it's like nothing but based on the variable similarity they want to do it. Okay, these are the terms people will not tell you. Even you will hardly find in some articles as well. So just want to clarify all this guy can do it. That's what here it is highlighted. Okay, so the way this KNN works is if you say like for example, these are a set of data points. If you see, it tries to draw a line that separates out exactly this point and this point. Assume these are two categories. Class A is one, class B is one. Something like gender male, gender female. Something like email spam or not spam. Something like employed, unemployed, educated, uneducated. Let's assume those two categories. If you want to discriminate or differentiate between them, you can use KNN algorithm. And whenever remember that in KNN, one rule is whenever you have even number of data points, like here in this case, there are only two categories. People always choose this K value as odd. That's been like a good practice kind of thing, because you do not have this type problem and all. And let's say you have three data sets. Okay, let's say you have 7 nearest neighbors. So here, when the nearest neighbors are there, you see, tries to identify which is the closest neighbor among all this. The way it happens is internally each object vote for it, and based on whoever vote for the same class category, they will be chosen into that particular bucket. Yeah, so it's the same thing which I was calling out, right? It's all based on the majority, whichever class, majority of whichever nearest neighbors are choosing a particular class. It's like a voting mechanism. They will put under the particular category. And this and all happens inside your KNN algorithm. You don't need to do anything. Don't assume that this is all I need to do. No, you need to just use the algorithm and the algorithm will do the job. But internally, this is what happens. And in order to figure out, like we are saying nearest neighbors and all that, but how does it figure out what is the nearest neighbor? It uses some kind of distance measure. Here we are using Euclidean distance, which is nothing but sum of squares. But if you look at, there are other measures also, like Manhattan distance and all that, cosine similarity. These are different distance measures. And each one of them are used based on the situation. And there is no standard rule to say that this is the distance measure you have to use. It all based on your data. So only when you understand properly your data, then only you can do something about it. Okay, guys, that's all I have. Thanks for the support. I hope this session helped you. We'll meet some other time. See you all. Bye.